Hello everyone, welcome to the third chapter of the course Introduction to Sustainability. In chapter 3, we will talk about the indicators of a human fingerprint on the Earth. The learning outcomes of this chapter are, so in this chapter we will talk about the difference between weather and climate. We will talk about global warming. So what does it mean, global warming? What are the causes and the consequences of global warming? We will talk about the 5 indicators that our climate is changing and also the evidences for reality of climate change. And then we will talk about greenhouse effect and the greenhouse gases. And I will finish by giving some recommendation or some steps to reduce global warming. What is the difference between weather and climate? Weather can change within a few minutes or hours. It means the same day. Temperature changes when the speed changes, pressure changes, precipitation also changes. However, the climate takes a very long time to change. So weather describes the current atmospheric conditions at a particular place, such as temperature, precipitation, wind, humidity, and pressure. However, climate describes the general weather patterns expected in a particular place, such as Michigan or the Arctic or the tropics. In other words, climate is a statistical average of weather over time. There are many factors affecting climate. Some of these factors are natural factors and some of them are human factors. The natural factors are the earth tilt, the water cycle, the Earth's rotation around the sun, and the volcanic eruptions. However, the human factors are the emission of greenhouse. How Earth tilt can affect the climate. So Earth tilt changes slightly over time, and the greater the tilt, the greater the differences in temperature between summer and winter. Earth is not a perfect sphere. It wobbles slightly as it rotates on its axis, and the wobble affects the intensity of solar energy that is received by the northern and the southern hemispheres at different times of the year. And this causes the changes in temperature between the seasons. Then how volcanic eruptions also can affect the climate. As you can see in the picture here, we have two cases. We have case A and we have case B. In case A, it is a case of small-scale eruption, so everything is normal. So the sunlight can reach troposphere. However, in the second case, it is a case of strong eruption. What it happens in this one? So here, the strong eruption, it can absorb the solar radiation and it can increase the albedo. So here, the causes, or it can lead to reduce the sunlight reaching troposphere, and it can reduce the temperature and cause cooling. Here we will talk about warming and heat. So actually, we can hear a lot about winter warming faster than summer, nights warming faster than days, more heat returning to Earth, a pattern of ocean warming, more fossil fuel carbon in coral, more fossil fuel carbon in the earth. So we hear a lot about warming and more heat. So here, this is what we call global warming. What does it mean, global warming? So global warming is defined as an increase in the average temperature of the Earth's atmosphere, especially a sustained increase great enough to cause changes in the global climate. Detailed research of climatic events of the past 150 years have revealed that the temperatures have risen all over the globe, with the warming occurring in two phases. The first phase was from 1919 to 1940, with an average temperature gains of 0.35 degrees Celsius. And the second phase was from 1970 to present, with an average temperature gains of 0.55 degrees Celsius. And records show that the past 25 years have been the warmest time of the past 5 centuries. What are the consequences of global warming? The consequences of global warming are the change of climate, the melting of polar ice caps, the increasing of sea level, the flooding in coastal area, the ocean acidification, and the change of wildlife adaptations and cycles. I think all of these consequences are clear. However, what does it mean, ocean acidification? So to know more about ocean acidification, we have this picture here to describe the process of ocean acidification. So what it happens in this case? So here, as you know, power plants release carbon dioxide, which ends up in the ocean. So now the CO2 with the seawater and the carbonate from the water can form what we call a carbonic acid. And here in this case, now the ocean become acid. Not only this consequence, but also it can affect the coral. Why? Because coral uses carbonate to build their shells. So here the decrease of the amount of carbonate available in the ocean can affect the shells, and it can reduce the ability of coral to build their shells. So here also coral cannot build their shells, and also the acid can degrade their shells. And here it can affect the health of coral reef. Affecting health of coral reefs can affect, of course, the fish that depend on coral reefs, and also the human communities who rely on the fish for food and economy. What are the evidences or the indicators that our climate changing? There are 5 indicators. The first 2 indicators are about the temperature on land and temperature of ocean. The graph here presents the change of temperature between 1880 and 2018 of ocean, land, and land-ocean. So it is obvious that the temperature increased between 1880 and 2018. Let's start talking about ocean. So roughly, as you know, 70% of the world is covered by oceans. So you can understand how hotter air over our oceans could make a big difference in the climate system. It is simple. As the air near the surface of the oceans get warmer, so more water evaporate. And so the result, stronger tropical storms, more extreme precipitation events, and also more flooding. What about the air temperature over land? Also, the air temperature over land increases. So it's clear that weather stations on land show average air temperatures are increasing, and as a result, the frequency and severity of droughts and heat waves are increasing. And the intense drought can lead to destructive wildfires, failed crops, and low water supplies. The third indicator is the increasing of sea level. In this graph here, you can see the change of sea level between 1880 and 2018. And here we can see that there is a huge increase in sea level. Let's say between like -10 till more than like 240 millimeters. So sea levels have been rising for the past century, and the pace has only increased in recent years as glaciers melt faster and water temperatures increase. And as you know, when the water temperature increases, so now the water of the ocean expand, and it takes more space or more volume. Consider how many millions of people are at risk as sea level rise, storms intensify, and more extreme flooding occurs. Additionally, as sea levels rise, salt water begins intrusion into freshwater aquifers, and many of which support the human communities and natural ecosystem. The fourth indicators is the melting of glaciers. As you can see in the graph here, the cumulative mass balance between 1940 and 2018. The disappearance of glaciers also is one of the clearest signs of the climate change. The last and the fifth indicators of climate change is the melting of the Arctic sea ice. So more than half of the Arctic sea ice is shrinking. Sea ice in the Arctic Ocean is going to hit its annual minimum, and they know, and is likely to be declared the second smallest summer minimum on record. Arctic sea ice melts during the spring and summer and defreezes in the fall and winter, and creating a natural patterns in sea ice extent that reach a minimum every September and a maximum in February or March. So when sea ice gets thinner, it also gets darker, and this allows more sunlight to get absorbed and exacerbating the warming process. Scientists point to the trend of thinning and shrinking sea ice as one of the many signs that the Earth is warming. So here, some evidences for reality of climate change. For example, about glaciers melting. So in Toboggan, Alaska, between 1909 and 2000, and here in Austria between 1900 and 2003, and here in Switzerland between 1858 and 1974. Flooding in many countries around the world in 2016 in Korowa, in 2016 in Louisiana, in 2012 and 2013 in India, for example, also in North America and in China and Russia. Droughts also in many countries or in many cities around the world, like in France in 2011, in Switzerland in 2011 also, in Brazil in 2010, and in Valencia, Spain in 2012.